Alright, next topic is gravitational force. Oh, you might think, oh, gravitational force is just Fg. I know it's equal to mg. No, you're wrong. But you're not that wrong because this topic is not really that simple. Because the actual formula for Fg is equals to g times m1 times m2 over r squared. Ooh, this looks a little bit harder. What is g? G is a constant. It's a gravitational constant. And G has an actual value which is 6.67 times 10 to the negative 11th. 11th. And what is ME? What is M1? M1 is the mass for the first object or the first planet. Mass of planet 1 or object 1. Object 1. The same as M2 is a mass for P1, the planet 2 or object 2. The radius, this r, is not the distance between object. It's the distance between center of mass. Distance between center of mass. It is very important. It's not the distance between objects. Let me give you some examples. There are two planets. This is a planet number 1. This is planet number 2. This is P2. This is P1. P1 has a mass of M1. Planet 2 has a mass of M2. And the distance from this planet to that planet is R. It is R0. Planet 1 has a radius of R1. Planet 2 has a radius of R2. Asking you, what are the gravitational force on each planet? Or the gravitational force that each planet act on each other. Alright, let's first write down the equation for each of them. Fg1 is equals to g, this never change because it's a constant, times m1 times m2. That's the mass of each planet, right? Just write it down. Times r squared. What is r squared? Just as I mentioned, the r is the distance between the center of mass, which means the actual distance, which is the r, is from this place, this position, to this position, which is this r naught plus this part, which is a radius, plus this part, which is the radius for planet number 2, which means r is actually equal to r naught plus r1 plus r2. So let's write it back. Let's write it down, which means Fg1 is equal to g times m1 times m2 over r naught plus r1 plus r2 squared. How about the second one? Do you remember on previously I tell you something about Newton's third law, like action force and reaction force? This is a pair of action force and reaction force because the gravitational force on P1 is that direction and is acted by P2, and for P2 it is pointing that way, which is opposite direction, right? And it's acted by the planet number 1, and they're relative stationary, so they're equal. But let's write it down first. Let's see if they're actually equal. It's equal to g. Fg2 is equal to g, is constant and will never change, times r squared. G times m1 times m2 over r squared. The r is still the distance between the center of mass, which we already figured out is r naught plus r1 plus r2, which we can write it down. G times m1 times m2 over r naught plus r1 plus r2 squared. Oh, they're actually equal. Which means, yeah, this is a pair of action and reaction force. Alright, now let's back to the basic. Fg is equal to mg. Yeah, Fg is equal to mg. You're right. And it's also equal to m1 times m2 over r squared times g. Oh, you can see there's a mass here, there's another mass here, there's another mass here, right? Let's see if they can cancel out. Let's still use this. Let's still use the previous example to planet. This is number one. This is planet number one. This is planet number two. This has a mass of m2. This one has a mass of m1. Yeah, that's right here, m1. Now, let me tell you the distance between center of mass is simply just r naught. And asking you, what is the gravitational field, or the gravitational constant, or the acceleration due to gravity on planet number one is, and ask you what is g2 on planet number two. So for planet number one, Fg is equals to m1g, right? Because the planet one has its own mass, which is m1 is equal to g times m1, the mass of the first planet, times m2, the mass of second planet, over r naught squared. Because this is just because r naught is just a distance between the center of mass, and I already told you, which is right here. And then, oh, m1 can cancel out, which means g is equal to g, which we can get little g is equal to big G times m2, which is the mass of that second planet, over r naught squared. Oh shoot, my bad. R naught squared. This is for G1. How about G2? Are they still the same? Are they still the like action and reaction pair, like I just told you? Actually, it's not. Let's see. Let's write an equation for the planet number two. Fg2 is equal to m2 times g equals, and it is equal to big G times m1 times m2 over r0 squared, r naught squared, and then we can get, because m2 can cancel out, right? So we can get g2 is equal to big G times m1 over r naught squared. These two are not equal. So the gravitational field on each planet can be different. And now you may ask, we already get the formula for the gravitational field. Can we use it? Can we use it for the Earth? Of course we can. Now, imagine an object is on the surface of the Earth with a mass m1. This is the surface of the Earth. This is m1. This is the box with m1, mass m1. Now, let's just write the gravitational force formula. Fg is equal to m1g, and it's equals to g times m1 times m2 over r squared. And now we can see the mass for the box is m1, right? And there's a mass over here. It is also the mass of the box, which we can cancel out. And this mass, m2, is the mass of the Earth. Which we can get g is equal to g times m2 over r squared. You can use this formula directly on your test or on your AP test, but remember, always cancel out the mass of the object, not the mass of the planet. Remember this. This is very important. If you mess it up, you will get the gravitational field like at 0.00000000000 something. So don't do it. Cancel out the mass of the object, not the mass of the planet. So let's plug the number in. The mass for the Earth is equals to, I search it up for you, 5.972 times 10 to the 24th. And then the radius of the Earth is 6.378 times 10 to the 6 meters. This is kilograms. Oh yeah, by the way, you may ask, the object is on the surface, so the distance is 0. No, it's not. It is the distance to the center of mass, the very center of the Earth, which is very, very far below the surface of the Earth. It's like this distance, which is the radius, is equal to this amount. So when you plug it in, you will get G is equals to, I think it's around 9.798 something. So you may get some number around this, which is very, very close to G equals 9.8. So yeah, so this formula works and it is absolutely correct. So you, oh, also I have to mention this again. Cancel out the mass of the object or use the mass of the planet, not the object that it gives you in a question.